Greetings. Welcome back to my channel. This is Kanye Samalawana. Today I would like us to focus on load conversion, series and parallel circuit. Load conversion can be found in many disciplines of engineering. For instance, in mechanical engineering, you will refer to transforming of one type of mechanical load with a certain torque and force into another form as load conversion for mechanical. In this session for today, we'll be focusing on electrical engineering load conversion, which is a terminology used to convert or transform one type of load into another. The most terminology that we'll be using in this session is delta and star. We'll be converting from delta into star connected circuitry. If you would like me to make a video on delta and star, please comment in the section below. To simply understand the terminology of load conversion in electrical engineering discipline, let's look at the following circuit. We have 12 volts DC battery with an H bridge connected loads. We have L1, L2, L3, L4, L5. L represent the load, which is L1 load 1, L2 load 2, L3 load 3, and so on. And we have a source current of unknown at this point, and the aim is to calculate the value of the source current that is drawn from the battery to supply the load that is connected in that form. Applying series and parallel in this schematic cannot be possible, as you can see that we can't identify which circuits are series and which circuits are parallel. 20 ohm and 5 ohm in L1 and L2, they are not in series nor they are in parallel. To solve this, we need to convert from one form of electrical circuitry into another, which is from delta into star. The first step into solving the circuitry in H bridge format is to convert from delta into a star connected circuitry. But before we do that, we will need to organize the circuit to delta in a way that we can understand as a delta shape. So we can do that as follows. Now that our load has been organized in a way that we understand, in a form that we can all comprehend with as a delta shape, with L1, L2, L3 forming the delta circuitry, we are in a position to convert the top portion of the circuitry, which is delta, into a star connected circuitry. To do that, we will need to have our values of A, B, and C as connected in star. To obtain the values of star connected circuitry, we will need to use the load conversion formulas from delta to star. To find the value of A, the formula is L1 times L2. You multiply the values of the delta connected circuitry on the side of that specific value, and then you divide by the sum of all the components that are connected in the delta circuit. In this case, for A, it's going to be L1 times L2, and then you divide by the sum, which is L1 plus L2 plus L3. To get B, it's going to be L1 times L3, and then you divide by L1 plus L2 plus L3, which is the sum. To get C, it's going to be L2 times L3, and then you divide by L1 plus L2 plus L3. One thing that you must notice is that the denominator, which is the bottom part of the formula, is the same, is the sum of the values in delta circuit, and then the numerator, which is the top part, it's the values that are constantly changing based on the location of the value that you want to calculate. To move to our next step, we'll need to calculate the values for the star connected circuitry. To get the value of A, as the formula says, L1 times L2 divided by L1 plus L2 L3, we substitute the values of L's 20 times 5 divided by 20 plus 5 plus 5. That will give you 3.3 ohms. To get the value of B, you do the same. You just substitute from the formula with original values of the delta connected circuitry, and it looks like it's the same values, so you're going to get 3.33 ohms as well for B. To calculate C, you substitute L2 and L3 with the actual values, which is 5 and 5. 5 times 5 plus 25, you divide by 30. Then you're getting your actual value for C, which is 0.833 ohms. The next step after obtaining the values of the star connected circuitry is to update the converted circuit. Now that our circuit has been converted, we need to calculate the total resistance. It's going to be a bit easier because now we are able to see which circuit is connected in series and which one is connected in parallel. As we can see in our schematic, B and L4 are connected in series, C and L5 are connected in series, and both totals of those series circuits are connected in parallel, with 3 connected in series with that total. To do that, we will need to perform some few calculations. Now that we've obtained the total resistance value, we can be able to calculate the source current that is drawn from the 12 volts battery by the H-bridge connected circuit. Applying Ohm's law, which is I is equal to V over R, we can be able to get the value of the current, with the voltage being 12 volts and total resistance being 8.46. The total current drawn from the battery is 1.42 amp. To understand the circuit a bit better, I've managed to obtain some practical example of the circuit with a simulation in Unveiled, whereby I use the values that we used in our circuit with 12 volts battery, and the switch starts to show when there's flow of current and when there's no flow of current. As we can see, the value that is obtained is not far from the value that we have actually calculated. That will be the end of our session today. Please drop your comments on the comment section below. Any questions or queries? Don't forget to subscribe for more insight. Until next time, stay curious.